Educator.com. Today's topic is slope and rate of change. Rate of change is defined as the change in y over the change in x. In other words, the rate of change is the difference between two values of y and two values of x. For example, if I have pairs of numbers such that x is 2, y is 3, x is 4, y is 7, I could describe the rate of change as y2 minus y1 over x2 minus x1, where this first set is x1, y1, the second set is x2, y2. So this equals the rate of change. Using that formula, I substitute in x2 is 7 minus x1 is 3. So y2 minus y1 over x2, which is 4, minus x1, which is 2. And that comes out to 4 over 2, or 2. So in this case, the rate of change was 2. I could have actually done it the other way. I could have said y1 minus y2 over x1 minus x2. But I can't mix them up. I can't say y2 minus y1 over x1 minus x2. You have to do both the x's and y's in the same order. You have to handle the pairs in the same order. By convention, it's usually done as y2 minus y1 over x2 minus x1. And it's a good idea to just pick one way and stick with it so that you're not changing around and risking doing the numerator differently than the denominator. The slope of a line in the xy plane is defined to be the change in the y coordinates over the change in the x coordinates. And if I have two pairs of coordinates, the first coordinate pair, x1, y1, and the second pair, x2, y2, then I can look at this slope formula as y2 minus y1 over x2 minus x1, where x1, y1, and x2 and y2 are members of those coordinate pairs. What slope describes is the steepness of a line. It tells you how steep the line is. For example, if I have a line that looks like this versus one that looks like this line might have a steeper slope, will have a steeper slope than this line. So it's going to have a larger absolute value. For example, perhaps the slope of this line is 8, and perhaps the slope of this line is 2. But remember, I mentioned absolute value. And the reason we talk about absolute value is the negative and positive sign doesn't tell you about steepness. It just tells you what direction the line is sloping towards. Is it going this way, or is it sloping up towards the right? That's what negative and positive tells you. The absolute value tells you about steepness. So if I have a slope of -3 and I have another slope of -4, and I take their absolute value, so the absolute value of -3 is 3, the absolute value of -4 is 4, this line is going to be steeper. So again, the slope of the line is the change in y coordinates over the change in x. So if I have two coordinate pairs on a line, I can use that to find the slope of the line. I just mentioned that the negative or positive sign tells you whether or not the line is increasing from left to right, right to left. It's telling you the direction the line is increasing from. So the absolute value of a slope tells you how steep the line is. The negative sign or positive sign tells you the direction the line is going in. Okay, for example, If I have a line that increases from left to right, it would look like this. And this would have a positive slope. For example, the slope could be 4, it could be 3/2, it could be 1. Okay? So lines that are increasing, the values are increasing as it goes from left to right, have a positive slope. If a line has a negative slope, then it's actually going to be decreasing from left to right. So this line would have a negative slope, such as -1, -5, -1/2. The steepness of these lines is determined by the absolute value of the slope. So if this has a slope of 5, -5, the absolute value is 5, that would be the same steepness as a line going in this direction with a slope of 5, which also has an absolute value of 5. So to find steepness, you look at the absolute value. To determine the direction of the line, you look at whether it's negative or positive. So we talked about if there's a positive slope. We talked about if there is a negative slope, what we see, and there's two other possibilities. One is that a line could be horizontal. In this case, the slope is 0. And that actually makes sense because slope is the change in y over the change in x. And if I look here, there is no, for this value, there is no change in y. Y is always the same value for every point along this line. The change in y along this entire line is 0. Therefore, you would end up with 0 for the change in y divided by the change in x. The slope is 0. Vertical lines present a different situation. For a vertical line, the slope is undefined. Again, looking at the slope equation, change in y over change in x. Here, there is no change in x. X is a certain value everywhere along that line. So if I take x2 minus x1, I'm going to get 0 because these values are all the same. There is no change in the x value. Therefore, that would force me to be dividing the change in y by 0. Dividing by 0 is disallowed in math. You cannot define the slope then in this situation. So we have 4 cases that we have a positive slope that tells us that the line increases from left to right. We could have a negative slope telling us that the line decreases as we go from left to right. We could have a horizontal line, in which case the slope is 0. Or we could have a vertical line, which means that the slope is undefined. In the first example, we're going to go back to talking about rate of change. Find the rate of change represented by the table. So looking at this table, I have a set of x values and a set of y values. Remember that the formula for rate of change is the change in x, change in y over the change in x. So the change in y over the change in x. So what I need to do is take two sets of values, and figure out what the rate of change is. And I'm going to take my y2 minus y1 over x2 minus x1. And I could pick any two pairs. I'm going to actually select, for my first pair, I'm going to select 0 and -4. And I'm going to select, correction, that is -4, 0, and 2, -8. So I'm going to have two pairs that will give me x1, y1, and x2, y2. Okay. So if I use these pairs in my rate formula, I'll find that y2 is -8 minus 0 over x2, which is 2, minus x1, which is negative 4. This comes out to negative 8 over 2 plus 4, and that equals minus 8 over 6, simplifies to negative 4/3. So the rate of change here was actually negative 4/3. And I could have used another two pairs since the rate of change is constant. The rate of change is the same. So x is always increasing by the same number. Y is also changing at the same rate. Here it's shown to be decreasing by 4 in each case. Therefore, this is consistent rate of change, and I could choose any two pairs to use in my rate formula. Find the slope of the line passing through the points -3, -7, and 6, -8. Okay, recall that the formula for slope is the change in the y coordinates over the change in x coordinates, or y2 minus y1 over x2 minus x1. And here I have two sets of points. And I'm going to call this one x1, y1, and this one x2, y2. Again, I could have flipped these around. I could say y1 minus y2, x1 minus x2, as long as I make sure that I handle the numerator and the denominator in the same order and I don't mix and match. So in order to find the slope, I'm going to substitute in y2, which is negative 8, minus y1, which is negative 7, over x2. So for x2 I have 6 minus x1, which is negative 3. To simplify this, I see that this is minus 8 and minus negative 7, that's plus 7. 6 minus negative 3 is 6 plus 3. So minus 8 plus 7 is 1. Negative 1. 6 plus 3 is 9. So I have a slope of minus 1/9. Looking back, what I did was to recall my slope formula, y2 minus y1 over x2 minus x1. And then I substituted in these two coordinate pairs that I had, simplified the equation, and ended up with a slope of minus 1/9. This next example says that a line passes through the points -9, -7, and -3, -2. Is the line increasing, decreasing, or neither? Okay, remember that if I have a positive slope, the line is going to be increasing. The line that this describes is going to be increasing as I go from left to right. If I have a negative slope, it's going to be decreasing as I go from left to right. So I need to figure out the slope, which equals y2 minus y1 over x2 minus x1. Therefore, the slope, here's my y2, is going to be equal to negative 2 minus y1, which is negative 7. X values, I have negative 3 minus negative 9. So again, this is x1, y1, and x2, y2, and I do them in the same order every time to avoid errors. Therefore, the slope is going to be minus 2 minus negative 7, which is the same as minus 2 plus 7, over minus 3 minus negative 9, so that's just going to be plus 9. To further simplify that, minus 2 plus 7 is 5, minus 3 plus 9 is 6. So I found that I have a slope of 5/6. And that tells me that this line is increasing as I go from left to right because it's a positive slope. And if I were to graph this out, I would find that to be true. So let's see, it's 2, 4, 6, 8, 2, 4, 6, 8, negative 2, negative 4, negative 6, negative 8. So I have two sets of points. I have minus 9, minus 7. So my first set of points, x is minus 9, which is right about there, and y is minus 7, which is right about there. And my second set of points is negative 3, negative 2. So an x value of negative 3, a y value of negative 2. So I have 2 points, and when I connect them, I see that it verifies what I found out by determining the slope, and that this line is increasing as I go from left to right. So what I did is I saw that I had 2 coordinate pairs, and I used those to determine the slope, which I found to be 5, 6, and that positive slope told me that this line is increasing. Okay, find the value of a so that the line passing through the points a, negative 4, and negative 7, negative 10 has a slope of negative 6/5. Once again, the slope formula is going to be used. And what this is telling me is that I have a slope of minus 6/5, so that's something I know. And it's also telling me that I have these 2 sets of coordinate pairs, except one of the values is an unknown. So I have a minus 4 and minus 7 minus 10. So I'm going to assign this first pair as x1, y1, and the second pair as x2, y2 to make sure I can keep everything straight and insert it in the formula in the correct order. Okay, y2 I know, it's negative 10, minus y1, and I know that as well, that's negative 4. x2 is negative 7, so far I'm fine. Now I get to x1, and it's an unknown. But that's okay because I have an equation here now with only one unknown, so I can solve for it. So simplify this to make it easier to work with. I get minus 10 minus negative 4, that gives me plus 4, minus 7 minus a. Well, this actually comes out to minus 10 plus 4 is minus 6, minus 7 minus a. Okay. What I have now is a proportion, and the way I can go about solving this then is to find the cross product. Remember, finding a cross product, I'm going to multiply the denominator of one side times the numerator of the other, and on this side I'll do the same, the denominator of the right side times the numerator of the left side. So find the cross products. And what that's going to give me is minus 6 times minus 7 minus a equals minus 6 times 5. Minus 6, negative 6 times negative 7 is 42. Negative 6 times negative a is going to give me 6a. And that's going to equal negative 30. What I want to do is solve for a, so I need to subtract 42 from both sides so that I can isolate the variable. And that gives me 6a equals minus 30 minus 42, which is minus 72. Finally, divide both sides by 6, and that's going to end up giving me negative 12. So after all this, I was at last able to determine that a is actually negative 12. So what I did is that I realized that I had all the elements of my slope formula except for x1, which is a. So I plugged in negative 6/5 as the slope, substituted in the other values that I had, and then when I got it simplified to this point, I realized that I could use cross products to solve the equation, and this is what I ended up with. From there, all I had to do is isolate the variable to determine that a is negative 12. That concludes this lesson for Educator.com.